Domain is the placement of x values on the x-axis between a pair of endpoints or coordinate points.
Range is the placement of y values on the y-axis between endpoints. Camille and I are placed on a graph, and Sandy represents our domain. So 0 and 4 are the endpoints, and everything in between make up the domain.
So 0, 1, 2, 3, and 4. Turn around, Sandy.
Sandy now represents our range. So negative 2 and 6.
The range is -2, -1, 0, 1, 2, 3, 4, 5, 6.
And negative 2 and 6 are the endpoints on the y-axis.
All of these numbers are called outputs. All of the numbers in domain are called inputs.
The domain is found on the x-axis while the range is found on the y-axis.
If you don't quite understand how we got those numbers, we'll explain it to you later.
How do you get domain?
That's a great question, Sandy. Well, I'm here to show you how. In the previous example, we told you that the domain between Camille and Rhea was 0, 1, 2, 3, 4. The way we got this is that we took out of account the y values so that our points would be endpoints on the x-axis. The domain is the values on the x-axis, but it also includes the endpoints. So our domain will become 0, 1, 2, 3, 4, just like we said in the previous example.
Okay, that's domain, but what is range?
Another excellent question, Sandy. Well, in the previous example, the range was -2 to 6, but finding range is a little bit different than finding domain. It's the same concept, though. So we're gonna take out of account the x values this time. And so our endpoints will be on the y-axis. And so the values between the endpoints is called output. And so you just find the values between the endpoints, and this will be your range. And so it will be the same as this.
A line is made up of infinitely many points. However, a line segment is not, because there are still too many points for us to write down. That's why we use interval notation when doing domain and range to help the process go a little bit easier. When writing domain using interval notation, you disregard your y values because you're finding domain, which is your x values. So you do 0 is less than or equal to x, which is less than or equal to 4, because those are the 2 points on the x-axis. Range is the same thing, except you disregard your x values because range is the y values. So you have -2 is less than or equal to y, which is less than or equal to 6, because the points -2 and 6 are found on the y-axis.
We use number properties to
Solve all different kinds of equations. There are multiple kinds, so we're going to show you them.
One example is commutative property, and there's addition and multiplication. For example, addition would be a plus b equals b plus a. The order of the two numbers does not affect the value. Commutative property of multiplication would be a times b equals b times a.
Again, the order of the two numbers does not affect the value.
Another example is associative property. There's addition and multiplication.
For example, associative property of addition would be a plus b in parentheses plus c equals a plus b plus c in parentheses. The example of multiplication would be a times b in parentheses times c equals a times in parentheses b times c.
The grouping of two or more numbers does not affect the value.
Next, we have identity property. This also has addition and multiplication.
For example, identity property of addition is a plus 0 equals a, and for multiplication, it is a times 1 equals a. The identity element for addition is 0, and the identity element for multiplication is 1.
The identity element is a number that combines with another number without changing the other number. 3.
Multiplication property of 0.
For example, a times 0 equals 0, or b times 0 equals 0.
Any number multiplied by 0 is always 0. 3.
Distributive property.
For example, a and b plus c in parentheses will equal ab plus ac, because you take the a and you distribute it between what's in parentheses, which will give you ab, and then you keep the sign in between and then ac, and that's how you get this.
Give it numbers.
For example, again, if you substitute in numbers and you have 2, 3 plus 4, it will equal 2 times 3 plus 2 times 4, which will equal 6 plus 8, which equals 14.
A number is distributed evenly to other numbers within parentheses. 3.
Inverse property. For this property, there's addition and multiplication.
For example, inverse for addition would be negative a plus a equals 0. The additive inverse must equal 0, and the multiplication inverse must equal the reciprocal. So that would be a times 1 over a equals 1, because these two will cancel out, leaving you with the 1.
An inverse element is a number which combines with another number to equal an identity element. Identity.
Reflexive property of equality.
For example, a equals a, b equals b, and if you were to substitute in numbers, you could have 1 equals 1, 2 equals 2, and so on.
Anything equals itself.
Symmetric property of equality.
If a equals b, then by rule, b equals a. If we substitute in numbers, if 2 plus 3 equals 6 minus 1, then 6 minus 1 equals 2 plus 3.
Both sides equal the same thing, just written differently on both sides.
Transitive property of equality.
If a equals b and b equals c, then by transitive property, a is equal to c. If you put this in number form, if 2 plus 4 equals 6, and 6 is equal to 3 plus 3, then 2 plus 4 is equal to 3 plus 3.
Substitution property.
If a equals b, the a may be replaced by b in any expression. So for example, if 6 plus 2 is equal to 8, then 6 plus 2 equals 5 plus 3 can be changed to 8 equals 5 plus 3 by substituting the 8.
Okay, Camille, now it's time for me to quiz you. So this is water bottle A. If water bottle A times Camille plus me, then it equals water bottle A Camille plus water bottle A Sandy. So what property is this?
That is distributive property.
Good job!
Hey Sandy, do you want to help name some properties with me?
Okay!
So let's give this pot a name. Since these are the same pot, we're going to name them both pot A. If pot A is equal to pot A, what property is that?
Reflexive property.
Good job, Sandy. Okay, Sandy, try this one. If this water bottle is called A, this one's called B, and this one's called C. A equals B, B equals C, so A equals C. What property is that?
Transitive property.
Great job.
Next, we're going to solve proportions. A proportion is an equation that states that two ratios are equivalent, and a ratio uses division to compare two quantities. So, for example, A over B is equal to C over D. You would cross multiply because that's your next step. So you use cross products to solve proportions. So you would do AD equals CB. Now, if we substitute numbers, and we can do 2 over 4 is equal to 3 over 6. And to solve a proportion, when you cross multiply, you would have 12 equals 12. Okay, our next example will be using variables. So you could do 4 over 8x is equal to 12 over 24. Now, you must cross-reduce to make it this easier, but say you didn't know that, you would still come up with the same answer. You cross-multiply and you would get 96x is equal to 96, which is x equals to 1. However, if you did cross-reduce, you would get 4 over x equals 12 over 24. So you would say 8 divided by 4 is 2, and 12 divided by 4 is 3. You say 4 goes into 24. So you do 1 and 6, because 4 times 6 equals 24. Now when you cross multiply, you would get 6 equals 6x. Also x equals 1. Or you could just reduce your fraction and you would get 1 over 2x is equal to 1 over 2. 2x is equal to 2. X is also equal to 1.
There are many different ways to solve proportions like this. Moving on to linear functions. Linear functions are a function that can be represented by a straight line on a graph. There's 3 different forms you can write linear equations into. The first is slope-intercept form. Slope-intercept form is written as y equals mx plus b. This form is the easiest to graph. That's why we're doing it first. M is the slope, or the rate of change. B is the y-intercept. If I give you the equation y equals 1/2 x plus 2, how would we graph that? Since 2 is the y-intercept, we would find 2 on the y-axis and mark it. And then, since this is the slope, it's the rate of change.
Hey, Camille, your slope is positive.
Oh yeah, that too. So when a slope is negative, it goes this way on your axis. When a slope is positive, it goes this way. Since our slope does not have a negative sign in front of it, it's positive. So we would go up 1 interval and to the right, since it's positive, 2. And that's your first point. And then you would do that again. Up 1 over 2. Since now you have 3 points, you can connect them into a line. You must remember to always put arrows on your lines because lines are infinite. And so we can't graph an infinite distance, so we put arrows to represent the infinite distance. The next form of linear function equations is called standard form. The equation for this is ax plus by equals c. there's a couple of things about this equation that you have to have. A can never ever be negative. And A, B, and C must all be whole numbers. And A and B both cannot be 0. So I've had my friend Sandy come join us so she can tell me whether or not the examples I give her are standard form or not. Okay, Sandy. Is this a standard form equation?
No, because the negative 2x is negative, so that can't be standard.
A in this equation is negative, which is a rule that we stated earlier cannot happen. What about this one, Sandy?
No, because the y is 0.
B cannot be 0. That's another rule we stated earlier. Good job, Sandy. Let me give you one last one. Is this one standard form?
Yes.
Good job. And our final form is point-slope form. Point-slope form is where if I would give you a set of coordinate points, you could plug it in and use any and convert it into the other linear equations. So point-slope form is y minus y1 equals mx minus x1. So if I gave you the coordinate point 3, 1, and 6, -7, you would put, so this is y, or I could just give you 1. We don't need to. So y minus y1, so 1 equals, oh, I also have to give you the slope, which we're going to say is half. So half times x minus 3. And that's point-slope form. And then you can take this point-slope form equation and convert it into any of the other forms. So if you want to do that, you have to get y all by itself. So you have to add 1 to both sides. Just kidding. You need to stop it there and copy when you finish, because I did it wrong. I forgot to distribute. Half.
So it's okay, Camille. We'll just erase your +1, and why don't you distribute first and then add the 1?
Good thinking, Rhea. So you have to distribute half. Okay, so 1/2 x minus 1.5 equals 1/4. So now, since I've distributed half into x and 3 using distributive property, I can subtract or add 1 to both sides. So that would be y equals 1/2 x minus 0.5. And now it's in slope-intercept form.
Talking about slope, if 1/2 is rise over run, and you have a whole number such as just 4 or just 1, it would be rise 4, run 1, because anything over 1 is the...
Sandy is about to go on an adventure to find a system of equations. What's that, Sandy?
It's one part of the two-part system of equations.
What does it say?
X plus 4y equals 8.
Okay, let's find the other part. What's that?
This is the second part of the 2. So this is x plus 2y equals 6.
What are we going to do with these two equations?
We're going to solve for either x or y. Okay, so we're going to solve the system using elimination. So the first equation is x plus 2y equals 6, and the other one is x plus 4y equals 8. So to solve it, we're going to multiply this equation by -1. So the two x's can cancel out. So once you multiply this by -1, it becomes -x minus 4y equals -8. So now we can cross these two out. So it leaves us with the 2y and -4y. So now we add these two and it becomes -2y equals -2. So we want the y by itself, like as a 1. So we divide it by -2
On both sides.
on both sides. So now it's y equals 1.
So now that we have established that y equals 1, we need to plug it into one of the equations. Usually we do this in the easiest, simplest equation with the smallest number. So I'm going to use x plus 2y equals 6. So x plus 2 times 1, because y equals 1, equals 6. So 2 times 1 is 2, so x plus 2 equals 6. And then we're trying to isolate x, so we subtract 2 from both sides, so x equals 4. And using our two values, we established that the solution to this system of equations is 4, 1.
This time we're going to do substitution. In substitution, we're going to substitute for x or y. In this case, we're going to substitute for x by moving 2y and 6. So we need the 2y on this side so we can move it where x is. So we're going to subtract 2y and it's going to become x equals -2y plus 6. So now we can move this part where x is because x equals this. So now we put -2y plus 6 plus 4y equals 8. And then we're going to combine like terms, and then it's 2y plus 6 equals 8. And then next we subtract 6 from both sides. So we get 2y equals 2. And then we just divide by 2. And then it equals y equals 1.
So now we're going to substitute y in as 1, so x plus 2 equals 6, and subtract 2 from both sides, so x equals 4. So the solution to this system is 4, 1. Using both types of solving systems of equations, we still get the same answer, 4, 1. This is the basics of quadratics. So this is called a parabola. There's certain things on a parabola that you must know to use quadratics. This is the vertex. It's the highest point on the parabola. The place where the parabola intersects with the x-axis are called zeros, roots, solutions are x-intercepts. All those mean the same thing. And this down the middle is the line of symmetry. If you cut it in half, both sides are exactly the same.
And the parabola doesn't always have to be on the y, like the vertex doesn't always have to be on the y-axis. It can be anywhere.
This is the parent function of a quadratic, y equals x squared. So quadratics, if x is negative, it's a minimum, so the parabola opens upwards, and if it's a positive x, the parabola opens downwards, so it has a maximum vertex. If a, the variable in front of x, is greater than 0, the parabola gets skinnier, and this is called vertical stretch. If a is greater than 0, the parabola gets wider, and this is called vertical shrink.
This is how you graph and solve inequalities. So you treat this like a normal equation and you graph it. So plus 6 would be your y-intercept. So 1, 2, 3, 4, 5, 6. And then you rise 2 and then run 1. So up 2 over 1. And then down to here. So this would be your line, and then you graph this one, which would be up 8. So up here, and then because we don't have any more space, we're just gonna go down 4. So 1, 2, 3, 4 over 1 right here. 1, 2, 3, 4 over 1 would be right here. And 1, 2. And this is your other line. And then because these are inequalities, you're going to substitute in any points, but we do 0, 0 to make it easier. So it would be so 6 is greater than or equal to 0. That means that 0, 0 is a point in the inequality. So if this is 0, 0, and this is the first sign we made, then all of this is shaded in, and this one is. So it's true that 8 is greater than or equal to 0, so you take this line and you shade it all in. So basically, all of this section right here is shaded in by both the lines. And always remember that if it is divided or multiplied by a negative number, the inequality sign is flipped.